Right, so to create a vector in MATLAB, it's quite easy. Same thing to create a matrix. You use square brackets and put the values you want inside it. And the values can be separated by spaces, as they are in this example, or by commas. It's entirely equivalent. Okay. And so that creates a row vector. And a row vector is, as you might expect, just a vector with 4 elements that goes horizontally. However, let's say we want to create a column vector. So recall, columns usually go vertically. Columns go up and down, like the columns in front of a building. And so to create a column vector, what you do is use the semicolon. And the semicolon in MATLAB, when you're creating a vector or matrix, just think about it as meaning skip to the next row. So here we say y equals 1 semicolon 5 semicolon 8 semicolon 9. That creates the vector 1, skip to the next row, 5, skip to the next row, 8, skip to the next row, 9. So now we have a vector and a column vector. So what if we want to make a matrix? And a matrix, just has a number of rows and a number of columns. Well, just basically go row by row, and whenever you want to go to the next row, insert a semicolon. So this z equals 1, 2, 3, semicolon 4, 5, 6, is 1, 2, 3, go to the next row, 4, 5, 6. So it's a matrix with 2 rows and 3 columns. And the order I said these is quite important. That's the convention we're always going to use. Rows first, and then columns. So if I say I have a 2 by 3 matrix, that implies 2 rows and 3 columns. So row 1, row 2, column 1, column 2, column 3. All right. So there's a couple of other easier ways to create large vectors quickly, as long as they have some sort of a pattern. So let's say if we wanted to create a vector of the integers from 1 to 1,000. Well, this first MATLAB statement, a equals 1 colon 1,000, does just that. So here, that creates a vector. It's 1, 2, 3, 4, 5, 6, all the way up to 99, 1,000. Or sorry, 999, 1,000. Right? So essentially, it's just skipping by 1, going from this starting point, 1, to this ending point, 1,000. Right. So what if you wanted to skip by something other than 1? Well, 1's just the default. You can specify skipping by something else. So here we can say, give a starting value, starting value, colon, how much we want to skip by each time, another colon, and then the ending value. So here, if we say we want to go from 1 to 1,000, skipping by 0.1, we'd end up with this following vector. 1, 1.1, 1.2, 1.3, and so on, all the way up to 999.9, 1,000. Great. We can also skip by negative numbers. So if we wanted a vector where the numbers descend, we could do this. Go from 0 to negative 100, skipping by negative 1 each time. And that creates the following vector. 0, negative 1, negative 2, negative 3, all the way down to negative 100. So that's the colon operator. You use that when you want to create a vector and you know how much to skip by between each element. So what if I gave you the task of creating a vector of, let's say, 1,000 points between 0 and 3, or something along those lines, where you know how many points you want to have, you know where you start and where you stop, and you want them all to be evenly spaced. Right? And this isn't as contrived or inane an example as you might think. In about 2 lectures, when you learn how to do plotting in MATLAB, that's actually it comes up quite frequently. And so here, to do that, we use the function linspace. And this basically creates a linear space, a vector where all of the points are equally spaced out from some starting to some stopping point. So here, linspace 0, 9, 4, what that's going to do is create a vector where the first element is 0, the last element's 9, there's 4 points in total, and they're equally spaced out. And so equally spacing out from 0 to 9 with 2 more points is 3 and 6. Okay? And you can do that with any arbitrary number of points. It doesn't have to evenly spaced out like in this example. So here, if we want to go from 5 to 22 with 200 points, we could do that. Right? And so notice MATLAB has kind of a weird convention where with the colon, you go start, skip, and end. Whereas with linspace, you're saying linspace, start, and then end, and then the number of points you want. So with colon, start, and end are kind of the bookends. And in linspace, it's start, and then end, and then number of points. Okay. Also notice that linspace is a function, and so it's taking its inputs separated by commas. Right? With the colon operator, you're just separating these values with colons. Okay. So colon and linspace are the two ways to create vectors really quickly. Colon you use when you know how much space you want between each point. Linspace you use when you know how many points in total you want. Okay. And in both these cases, they create a vector. Okay. And interestingly, once you have vectors, you can combine them into bigger vectors or matrices. And so here, it's an interesting point. Here we create a vector C with 1, 2, and 3 in it. And then we create a matrix D where the first row is C. So 1, 2, 3. Then we go to the next row, and then we add in C again. So 1, 2, 3. And notice this isn't going to create a matrix containing two different vectors. It's going to basically smash all of this together. Right? And so for an even more clear example of that, you could have 1, 3, 4. And if you type that into MATLAB, what it will do is create one vector where it's 1, 3, and 4 are the elements. All right? So when you have basically vectors inside of other vectors or matrices inside of matrices, MATLAB just smashes it all together, assuming the dimensions work out, and you end up with one vector or one matrix in the end. Okay. And now we also have 3 special functions for creating certain types of matrices. We have a function called zeros for creating a matrix full of zeros. So here, if we only give it one element as its input, one number, it creates a square matrix, a 3-row by 3-column. Okay. And let's say we wanted to have a 3 by 4 matrix. Well, we could have just said zeros, 3, 4. Okay. And so the next version, or next function we have is called ones. And as you might guess, it creates a matrix full of ones. And here, 3 rows, 4 columns. Here we go. That's what it creates. Okay, it's interesting to notice zeros and ones are the two functions like this. There's no function twos, etc. Okay. Well, isn't that a problem, you might ask? Well, no. If we wanted a matrix all of twos, we could make one all of ones and just multiply everything by 2. And so this exact command would create a matrix all of 2s. Okay. I mean, similarly, you could create a matrix all of zeros and add 2 to each. Okay. And so there's a lot of, once you can make matrices of zeros and ones, you can make matrices of anything. Okay. And the third version, third special function for creating matrices is called EYE. And that's for creating identity matrices. Right. For those of you who've worked with matrices in math before, you realize that any matrix times the correct identity matrix, the correctly sized identity matrix, just returns the original matrix. It's basically the equivalent of multiplying by 1. Right? And what it is, it's a matrix with 1s down the main diagonal, and then zeros everywhere else. So normally in math, you're used to having this represented by like I. So there's a problem in MATLAB. You would think you would just create a function with the letter I. But you'll notice that I in MATLAB is already in use. It's the imaginary number. Right? So it's already used, we can't call the function that. So what the designers of MATLAB did is they decided to be funny and called it EYE. They just went with the homonym. And so it's corny, but that's how they defined it, so that's what we're stuck with. Okay, so EYE is the identity matrix. And so now we can make matrices in a whole bunch of different ways.